Okay, so I just like to share a short video on a weekend hack that I did, building an application in 24 hours to solve a particular problem. And the problem that I chose is trying to reimagine how contact tracing would work in the Philippines. So last year, during the height of the pandemic, a lot of contact tracing apps were released. However, we haven't really felt the effectiveness of these contact tracing apps. And I'll try to present some problems why that is so. And these days, especially with today, as of this recording, we're still in lockdown, and the situation is seems to be getting worse. Right? We have had 5-digit active cases identified over the past few days alone, over the past 7 days alone. Um, and contact tracing is very important if we want to lower the risk of the virus spread. So what are the problems and what's the proposed solution for it? So the problem is that we do understand that there's a need for proper contact tracing, especially in the time of pandemic. However, it's not properly implemented. Right? Each establishment had their own sort of contact tracing mechanism. Data is not aggregated, and uh, because if it were working, if the systems were working, then we should have felt the effectiveness of it. Okay. However, not all people have smartphones to begin with, and if even if they did have smartphones, they wouldn't have an internet connection, at least a stable internet connection. You all know that internet is terrible in the Philippines, and furthermore, people are lazy in terms of inputting information. Right? When you go to a restaurant, you'll have to scan input information over and over again for each new establishment that you go to. It's a grocery or a new restaurant that you eat in. And there's also that problem of data integrity because people don't put in the correct information. It would be very easy to masquerade as someone else, thus not making the system as effective as it should be. Okay, so there are a lot of other problems that we would probably identify with contact tracing in the Philippines, even if there are existing apps out there. There's no standard way to do so. Each LGU had their own different way of doing it. Each establishment had their own Google Forms, their own way of aggregating the data. So that problem is what we try to solve today, and the proposed solution is relatively simple. We simply reverse the process. We allow establishments to provide the connectivity. We'll talk about how we can solve this later on. And in order for people not to keep on repeating their information, then it would be nice to have some sort of centralized database, something like a national ID. An idea that has been floating around in the government for quite some time but hasn't really materialized yet. And the importance of this is that we want data to be aggregated, to be easily transmitted in a centralized system so that it can be effectively used by people in authority, government, Department of Health, and so on. And the system should be able to scale to large volumes by itself with minimal interventions possible, because if you were to imagine that all people in the Philippines would be using it, then that would amount to large volumes of information coming to the system. Okay, so how do we solve that? Well, the weekend hack that they did in 24 hours, we built 3 components. Very, very simple components. So let's just go through each part. So the first part is actually a thin client that would be deployed in establishments. So this thin client, the purpose of this client is to be able to scan a QR code representing the identity of a person that walks in, so a citizen. That identity can be something like a national ID, as long as that identifier is registered with the system. Which brings us to the second component, which is the application, the server running in the cloud or in some on-prem location. The purpose of that service is to be able to register these citizens so that they actually have a value for the identifier. Okay, so where all the sort of the records of citizens would be stored in a digital format. A QR code can be produced. That QR code can be easily printed out, attached to an ID, and that ID can be brought about wherever the citizen goes and have it scanned by the thin client. Now, the third component is actually the most interesting one for me, and it's the serverless part. So a serverless component is simply something that scales on its own. You don't manage it directly. The scalability of the system is managed by the cloud provider. So for example, in Amazon Web Services, they have this thing called AWS Lambda, and a serverless database such as DynamoDB for extreme performance in terms of reading and writing information too. So the third component, the serverless component, would store the data, capture the data in a highly scalable manner, and be able to store it in the form of logs, which will be read off by the system. Okay. So three components: a thin client, a centralized server, and a serverless component to capture all that information. All of which will not require the citizen to have an internet connection. You just have to bring their ID, have it scanned by the device, and the device will do its thing. The device doesn't even have to be online 24/7. It can store the information in the device itself. So let's say a Raspberry Pi with a camera system that can scan a QR code can store gigabytes of information, something that is more than enough for 24 hours work, and it would be sent, let's say, at night or at off-peak hours. That way we can still compromise with the lack of internet connectivity in each establishment. Okay, so to give a short demo of the hack, let's go ahead and check out the systems. Okay. And let's start off with the centralized system. So this is where we would build information of the establishments that are registered with the system. So let's say Philippine General Hospital. You can give it a description. Of course, the information can be extended later on. But the first thing we do is we create an establishment where these devices will be deployed in. Now not a single establishment will not represent a single device, but rather an establishment can have multiple devices. So let's say we configure these devices, and let's say device A, or rather let's be more specific. Let's say entrance A. Okay, we give it a serial number. The serial number is there to provide some level of security, maybe register the hardware serial number of the device that's being deployed. So let's just say 1, 2, 3, 4, 5, 6. It would have a system identifier, something like a secret to add for additional security, so that when data is sent by the device, it could associate if it's a valid device actually sending the information. It's something like an API key of sorts. And we associate it with an establishment. Okay, so serial number has been taken. It should be unique. Just enter some random numbers there. Okay, and we have our device. So let's go ahead and create another one. Let's say entrance B. Let's say the place actually had 2 entrances where the devices would be deployed in. Okay, so random serial number. Let's put it in Philippine General Hospital. Okay, so if you check out the establishment, you can see that we have 2 devices registered in it. Okay, so the setup would be that whenever we create a new device, we would have the actual hardware, input the necessary information, and deploy it in the establishment. Okay, so now that we have that set up, let's now register a citizen. Okay, let's say Juan de la Cruz at gmail.com. Okay, so of course this process would be how a citizen would be registered with the system. The system identifier would be that single unique identifier, ideally the national ID, and then of course you would have other information such as the address of that system. Of course this can be controlled by the LGUs, and certain policies can be applied to make sure that the data is correct. Okay, so once we create a record in that system, you can see here that it generated a QR code representing the system identifier. And the QR code, just being a simple image, can easily be printed out and attached to an ID for scanning later on. So what I'll do is I'll just take a quick picture of this QR code in my phone. Okay, so for use later. And that's it. That's the registration part. So that is the centralized server part of the system. Now let's move to the next component, the serverless part that would actually be performing the logging. So I can run this actually locally just for demo purposes, a serverless node in my computer. So it would be running a very simple API that accepts the scans done by the client. So I have it running here. It's now up and running. Let's see. Okay, it's now up and running here. I did some tests prior to this video. And so let's now move to the third component and see if it can actually capture the logs. So the third component would just be a thin client. In fact, the implementation that I did was a very simple React.js based client. So it's just a bunch of JavaScript, CSS files, HTML in order to scan the QR code. So let's go ahead and set up this device according to what we registered in the system. So let's say we set up a device for entrance A for the Philippine General Hospital. Let's go ahead and copy the system identifier and paste it in the configuration of the device. And let's just say we deploy it in the actual establishment. Let's go ahead and restart the server. Okay, so once that's deployed, you can go ahead to the actual app. So this app will be ran in each establishment, and all the citizen has to do is once they enter the establishment, they present the QR code. So let's just prepare that. The QR code that I captured earlier. Okay, and let's scan it. Okay, should scan. All right, and then once it scans successfully, it would say log complete. Okay, so again, what it did is that it sent the information to the serverless component. Again, the purpose behind it is that the citizen would not need any internet connection. Instead, they would just have to bring their ID with the identifier, assuming that it has already been registered in the system. Okay, so let's check via the centralized server. The centralized server will also interact with the serverless component, fetch the necessary logs from another API endpoint, and display it in the system. So we actually have two databases running, one for logs and one for the aggregated information, the centralized information. Okay, let's go ahead and go to the citizen. Right, and you can see that it was logged 4 times. Of course, I have to fix the delay from entrance A with a bit of offset. Of course, the problem can be fixed. Probably another 24 hours to do so. But just to make sure that it's actually working, let's try to configure a contact tracer for device B. So let's go ahead and get the system identifier for device B, entrance B. We'll copy that. Same process. We'll go to the configuration file of the device. Okay, let's restart the device. And let's say that that citizen goes to device B. Okay, so we refresh that, start the scan again. Okay, let's go ahead and scan the QR code. It should say log complete. There we go. And let's go ahead and go to the citizen again and see if their logs are not device B. Okay, so it fetches the log from the serverless component. As you can see, it logged it accordingly in device B. Okay. So that's the basic flow of the system. Just to summarize, again, we have 3 components. A client that will be deployed in each establishment. This client or this device is registered with the system with the appropriate security values in place. A citizen would also have to be registered to produce a unique identifier. A unique identifier can be printed out in the form of a QR code. Scan the QR code when the citizen enters the establishment and log the necessary information. Okay, so other challenges that will be involved. It's not really a technology um, problem because the technology is already available. Serverless technology can be easily provisioned via something like AWS, and the real problem really is still in governance. Okay, what are the policies to make sure that people comply with such regulation? For example, there should be like probably a law that says that if people misuse the information, because someone can easily borrow someone else's ID and have that scanned to pose as if that person was actually in that establishment. So the real problem is really in the policies that govern this process. And of course, competence in terms of maintaining and administering such a system. And of course, securing that system accordingly. So there are a lot of security holes that have to be patched. This is just a 24-hour hack, so of course I did keep I wasn't prioritizing security within 24 hours, but it can be improved on. Okay, so it's a proof of concept. As you can see, the system is working. You can actually reverse the process of contact tracing, and it can easily be done. Now, I'm not sure if I would want to push through this, if someone would actually use it. Hopefully, no one would use it because that would mean that the pandemic is over. But if it is useful for some establishment or if it is useful for some LGU, then people could make this possible. Probably a joint community effort by various developers. Very easy code. I could share the code with the community for the community to expand on. Okay. Right, so that was reimagining contact tracing, the weekend hack, and learned a lot of things in terms of how to integrate all these things together and work with serverless components in AWS. Right, stay safe, everyone.